For our 5.2 worksheet, if you know how to make equivalent ratios, you know how to make simplified ratios for that basic ratio, then you can just go ahead and do this. You do not need to do it with the video. If you know how to do it, just do it. If you are stuck, this video is a great place to go and get some help. So the first ones want us to make equivalent ratios. So we are either multiplying or dividing. We have to do the same thing to both sides. So if we look here, we have 2 and 6. So we need the greatest common factor to be able to simplify first. And then we use that to find the rest of the chart. So 2 can go into 6 and 2 can go into 2. So we're going to divide by 2 on both of these. So 2 divided by 2 is 1. 6 divided by 2 is 3. So every time there's one cat lover, there's 3 people that love dogs. 1 cat, 3 dogs. So now there's 2 cat lovers, so now there's 6 people, right? It just doubled there. So now we want to use this basic ratio, 1 to 3, to fill out the rest of the chart. So how do I get from 1 to 4? Well, I times by 4. So we need to do 3 times 4 here. So I'm going to let you figure that part out. If you know your math facts, this is pretty quick. If you don't know your math facts, we got some work we need to do. So now I come back to the basic ratio. How do I get from 3 to 21? So whatever I did to get from 3 to 21, I'm going to do the same thing over here. 1 times that same number goes here. So 3, 6, 9, 12, 15, 18, 21. I'll help you out on this one. So it's times by 7. So now I need to do 1 times 7 to go here. All right, so our next one, we have $8 every 2 hours. So every time it's been 2 hours, they've spent $8. So we want to go back to that basic ratio. So how do I get from 2 to 1? Well, I divided by 2. So how do I get, I need to do 8 divided by 2 is 4. So every time it's been 1 hour, they spent $4. Now it's 2 hours, they spent $8. At that same rate, what's going to happen? So we want to come back to this basic ratio here. So how do I get from 4 to 20? So count by 4s till you get to 20. 4 times what is 20? And you're going to do the same thing to the 1. Hey, this next one, we're going from 1 to 15.5. So how's that decimal in there? Well, 1 times n itself is that number. So we have 1 times by this is going to be 15.5. So we need to times by 15.5. So I'm going to do the same thing to the 4 and times that by 15.5. That means we're going to have to do that problem. 15.5, whoa, that got a little carried away there. And we're going to times that by 4. Now remember, multiplying is the only time we're not lining up that decimal. We're just going to take care of it when it's done. So we need to do 5 times 4. 5 times 4, add that number. 4 times 1, add that number. And then I have 1 decimal place, so my answer should have 1 decimal place. Hey, next up we have red marbles, blue marbles. So we can see here is what we know. If I have 4 red marbles, I have 8 blue marbles. So it wants to know, how do we get to 1? If there's just 1 red marble, 4 and 8 can both be divided by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So there's half as many red marbles or twice as many blue marbles. They're a half. 1 red marble, 2 blue marbles. Now I have 4, now I have 8. We can just see these are doubled. You should follow patterns across as well. So, right, this was divide by 4, divide by 4, divide by 4, divide by 4. Your patterns should go all of the ways. So now I'm coming back to this basic ratio. So how do I get from 1 to 6? Well, we times by 6. So now I need to do the same thing to 2 and times it by 6. Coming back to the basic ratio, 2 to 24. So you need to see how many times 2 goes into 24 and then do the same thing to the 1. So go ahead and see if you can finish filling that out. Hey, a grocery store charges $6 for every 2 boxes of cereal. Complete the table to make any equivalent ratios. So when they buy 2 boxes, it costs $6. We get to decide what's going here, but whatever we do to the 2, we have to do to the 6. So if this first one, if I times them both by 2, if I double them, I'm going to write, what did I do? 2 times 2 is 4. 2 times 6 is 12. So you can pick any number you want to multiply by. It just has to be the same one for the numerator and the denominator, or the top and the bottom. So I'm going to go 5. I'm going to say 5 here. 2 times 5 is 10. 6 times 5 is, not 60, is 30. So every time I'm coming back to the beginning. I didn't times 4 by 5. I mean, you can. That will be the same too, but you're going to get big numbers when you do that. So pick 2 other things to multiply the 2 and the 6 by. Pick something else to multiply the 2 and the 6 by. It has to be the same thing to keep it equal. All right, so now we're going to write the basic or the simplified ratio. So again, we're looking for that greatest common factor we can divide by. And then we're going to circle the 2 that are equivalent. So we have Maylee has 18 pens, 12 pencils. I said those totally backwards. 18 pencils, 12 pens. So I'm looking for the GCF. Factors are fewer. So 12 cannot go perfectly into 18. 11, no. 10, no. I'm just counting down. 9 does go into 18, but it doesn't go into 12. So we've got 8, no. 7, no. 6, yes. These can both be divided by 6. So 18 divided by 6, 6, 12, 18 is 3. 12 divided by 6 is 2. So 3 and 2 cannot get any smaller. They can only be divided by 1. So Maylee, every time she has 3 pencils, she has 2 pens. She gets 3 more pencils, 2 more pens till she has 18 and 12. Hey, Eric, we have 15 and 7. Can 7 go perfectly into 15? No. 6, no. 5, yes, but it doesn't go into 7 perfect. 4, yeah, we're on 4. No. 3 goes into 15, but not into 7. 2, neither of them are even. The only thing it can be divided by is 1. It is already as simple as it can be. He gets 15 pencils, 7 pens. Henry has 10 and 4. So can 4 go into 10 perfect? No. Can 3? No. 2? Yes, they're both even. We're going to divide these both by 2. 10 divided by 2, I'm going to let you write that there. 4 divided by 2, write that there. So we found the factor, we divided them, we're looking for ones that are the same. Okay, next up we have Julian has 15 pencils, 6 pens. So can 6 go into 15 perfect? No. Can 5? Yes, but it doesn't go into 6 perfect. 4? No. 3? Yes, we're going to divide 15 by 3 and 6 by 3. So now we have all these basic ratios. You need to circle the 2 that are exactly in the same order. Hey, next up we have the 4 math teachers here at our school this year, and how many girls they have in a class and how many boys they have in a class. We want to know which ones have an equivalent ratio, because they don't all have exactly the same amount of students, but which one is following that same basic pattern. So in Mrs. Richards' class, we have 15 girls, 18 boys. So we need the greatest common factor. Can 15 go into 18? No. Can 14? No. 13? No. 12? No. 10? No, right? We're just counting down until we find a factor. 9? Ooh, 9 goes into 18, but not 15. 8? No. 7? No. 6 goes into 18, but not 15. Let's go into both of them. Common, right? So we'll say on 6, 5. No, goes into 15, not 18. 4, no. 3, oh yes, we're going to divide these both by 3. 15 divided by 3 is 5. That was hard, apparently. 18 divided by 3 is 6. So every time there's 5 girls, there's 6 boys, and that's repeating that pattern 3 times. Hey, Mr. Warner has 18 and 11. 11 can't, 10 can't. 9 goes into 18, but not 11. 10, 9, I already said 9. 8, no. 7, no. 6, no. 5, no. 4, no. 3, no. 2, no. The only thing, 11 is a prime number. Its only factor is 1 and 11. So this one is going to stay the same. Okay, so I want you to try Mrs. Munns and Mr. Dunmeyer on your own. So find the number that you can divide 16 and 18 by. Find a number you can divide 10 and 12 by. Simplify and circle the 2 that are equivalent. And then get it checked.